Take it away. Okay, so this is what I do all day. People call me on the phone and I hooked up all this stuff and it's not working the way I expected it to, or it's not working at all, right? So these are the most common things people call me with. Obviously, there's probably 1,000 one at a time ones, but these are the ones that happen over and over. So, and they're not necessarily in any order. So we'll stick with me. Okay. All right. So obviously we got to take care of the easy ones. I can't believe I'm so stupid to have not done these. But obviously you got to have batteries that work. Trust me, I've I've had systems thinking something else was wrong, and it's like, oh yeah, check the batteries. So you got to have batteries. You got to have line of sight between your receiving and transmitting antennas. In other words, no obstructions, large set pieces. You can't put your antenna in a steel cage. We see that every once in a while. Somebody will put their antenna in a cage in a basketball gym or something. And also, you got to check your wires. That's the easiest. My whole history in audio, live sound, is the most likely thing to break is a wire. That's just what's going to break first. So let's check those. And so I'm going to assume that everybody checked all this stuff. So the first one I want to talk about, so there's kind of two parts to making a wireless mic work. You got to get the signal from the transmitting antenna to the receiving antenna and down into the receiver. That's the part, that's what we do at RF Venue. That's what we can help you do. But there's a second part to that. So even though you've got good signal and everything's working and all the electronics are fine, you got to have a place to tune your mics to where there's not a problem, right? So frequency coordination is becoming more and more and more critical every day. We used to have a lot of bandwidth and now we don't. So we have limited space. We got to pay attention to this. So simply put, all radios interfere with each other and they create intermods. So it's a simple thing. If I look at two microphones, you see the two frequencies I've tuned it to, but if I had this on a scanner, I would see two more frequencies. Now, how high they are in amplitude depends exactly where these are tuned, how far apart these are tuned, how much power they're transmitting with, and how much, how physically close they are to each other, right? So that's two, it's pretty simple. We got three microphones, and it's like all of a sudden, whoa, we got a whole lot more intermod. By the time you have 8, you have 42,000 possible spots. Now, most all of them are going to sit idle until somebody walks right to that one spot on stage and they're exactly in the position with the other mics, or, you know, Romeo and Juliet are singing the love ballad and they're arm in arm and their two transmitters are 6 inches apart. So this is a dance, it's moving. What frequency coordination does, you can't eliminate these intermods. They're going to be there. What frequency coordination does is it tries to assign frequencies to your wireless microphones so that the intermods don't bother those frequencies, right? So by shifting these frequencies around, we know exactly where these intermods are going to occur. So what we want to do is move them away from the channels that we've tuned to. You don't have to be exactly right on it for it to interfere with you. That depends on a whole bunch of things. But we'd like to obviously not drop another mic and put it right on top of an intermod. And then we don't want those intermods too close to the frequencies we're using. So you really need to use, you need to press the right button. So frequency coordination, this is the easiest way to do it. If you go to our website, at the top there's a performance tools button. It'll take you right to this program, Wireless System Builder. And this is really easy. You tell it where you are. You tell it what I have these mics in this block and these ears in this block, and it's going to coordinate that for you. Based on your geographic area. A better way to do it would be to include a scan, if you can actually measure where you are, because then it tells it all the things that it can't know ahead of time. So it knows a whole lot of things about you from geography, but it doesn't know if you have an X-ray machine on your stage, right? So if you actually measure the room, you can measure all the things that create interference in that room, and then the program takes that into consideration, right? So you got to remember, when you use these programs, they only work as well as the data you input to them. The more you can tell them, the better they work. Do you need it? Depends where you are. If you're trying to use 48 microphones in Times Square, yeah, you do. And if you're trying to use them on top of a mountain in Idaho, maybe not. And everything's in between. So you just want to do this. This is free. It's easy. You got to do it. Then the next thing you want to do, so you end up with this coordination, but it doesn't have every piece of data in the world in it. So what we want to do is a thing called wargaming, right? And so basically what I'm going to do is I'm going to spread out my transmitters, a foot or two apart like this to start with. I am pushing the wrong buttons today. And then what I'm going to do is like turn off channel 1, right? So I got the rest of them are all on. I'm going to turn off channel 1, and I'm going to go look at its receiver. And if I'm still seeing signal like I am in the top receiver here, it's either getting interference from something else or it's getting intermod from those other mics that are turned on. That should drop to 0, right? If it doesn't, I got to go back and change that frequency. And so I'm going to do that until that happens. Then I'm going to move on and do it with number 2, then number 3, then number 4, then number 85. So this can take a while or this can go quickly, but that's what happens. We've got a full video, step by step, how to do this, and it's about 6 or 8 minutes long, so I didn't want to include it here. I don't really have time for that. And frankly, Adam, if you could post this, I know you guys can't copy, you do a screenshot, but Adam, if you could post this.
Sure thing, Don. I'll send it over in the chat.
Yeah, put it in the chat, and then you guys got it. So if you want to go back and look at this step by step by step, this is what the pros do, right? This is what the guys that got to run 64 microphones at the Enormodome do, because the computer program's really good, but it's not always, it doesn't know everything, because you didn't measure it with all your transmitters on probably. So anyway, this is the thing you want to do to really, really lock down your frequencies and really make sure everything's working correctly. Okay, so this is one I get all the time, right? So we're talking about new equipment. If your system's been running for a year and now you have a problem, there's different things probably that are a problem. But this is like, I took brand new stuff out of the box, I hooked it all up, and wait a minute, I got all these mics, but one of them's not working. What's wrong? I don't know. So we got to go through this in a systematic method and kind of understand where it is we got to do. So we have to prove things, not guess, but prove them. So in this case, I'm showing 6 mics. I'm going to assume you've hooked them all up correctly to your distro and your antennas and all that. You've done everything right, but why is it not working? Well, the easiest thing to do, so going back to this, so these aren't real numbers, this is just to illustrate. So 50, 1, 2, 3, 4, 5, 6. If 6 isn't working, let's try tuning a channel to a channel that does work, right? So let's tune it to 505, or let's swap it with another one, right? Because now if we tune it to 505, and it works, but previously number 5 unit, now tuned to number 6, doesn't work, okay, then you've got a frequency issue. We need to retune that microphone to something else, right? Are we clear on how this works? We're not rewiring anything. All we're doing is we're taking a channel that didn't work and we're tuning it to a channel that does work, right? And now, because if it still doesn't work, then we've got a different problem, right? So if it still doesn't work after you've tuned it to a frequency that does work, the possibilities are we have a defective receiver, we have a bad output on our distro, not very likely but possible, or we have defective coax cables. Now, please do not tell me, but these are brand new cables. Brand new things don't always work. In fact, you know, industry average for these kind of things is like 1 out of 100 or 1 out of 200 is dead in the box, right? New parts, there's this thing called infant mortality syndrome. And yes, we check every one of these things. And yes, it goes through 85 computer checks, checking all the circuitry. But sometimes brand new transistors and brand new resistors just fail in the first hour of operation. It just happens. Otherwise, you do it like NASA and you spend $30,000 on it, on a 50-cent part just to prove that it's going to work. But we don't do that in the kind of stuff we're working with, right? So are we clear? If this has a frequency that we know it works, but it's still not working, the distro is either not sending it a signal, the signal's not getting there because the coax jumpers are wrong, or the receiver itself is defective. Now, going back to the coax thing, you got 2 cables, right? So even if one of them is working, it probably is going to look like it's working. It's not working good, but it should work. So just saying, the chances of having 2 brand new ones aren't good. So we can go back, let me back up to this a little bit here too. Like sometimes people, well, 4 of the channels are working and 2 of the channels aren't. That pretty well proves that the antenna is working and that the distro is working. It is possible some of the outputs are bad. That's really unlikely. It's just, it could be, but it's not likely. So if you're trying to make 16 channels work and 4 of the channels don't work, the clear, most likely problem is you don't have a good frequency coordination, right? That is way 10 times, 100 times more likely than you've got broken gear, but you could have broken gear, right? So the easy way to check, if you don't have a lot of equipment, just physically swap out that receiver with another receiver that does work. And if the receiver that worked, you know, on channel, well, I took the one from channel 5 and I plugged it in physically to the outputs of distro number 6. I used the cables from distro number 6. And if the receiver is not working at that point, because it did work when it was plugged into 5, if it's not working when it's plugged into 6, then the distro or the cables are bad. If it does work, then it pretty much suggests that the receiver itself is bad, and you'll have to run that, check that out and run that down, right? So, yeah, we got that.
Well, Don, real quick, I want to add some, but definitely what Don is saying is when you're troubleshooting, you have to do it systematically and in order. You have to be organized. You can't just throw it out there. You got to figure out where the problem follows, is the way we say it.
Right.
Where's the problem follow? So be very intricate with that step. It's you may have to be in a hurry doing it, but man, if you dig yourself a bigger hole, you're going to be wishing you didn't.
Yeah, when we dig in a chain of things, so we're dealing with a chain of things, right? So it's a little, you know, people call me sometimes with a chain of things and tell me, well, I got a bad this or a bad that. And it's like, well, how do you know? Well, it's not working. Well, it's kind of like in an audio system, right? So you got a microphone going into a mixer, going through an EQ into a power amp and coming out the speaker. If you don't hear the sound, don't call me and tell me the speaker doesn't work unless you proved it. Yeah. Because it could be anything in that chain. All you know is you don't have output. And it's the same thing with this. All you know is it doesn't work. Very systematically go back. You can't skip any of these steps because then you don't know where you're at, right? You might get lucky, But if you do it very systematically, like Richard says, you're going to find where the problem is, and then you're going to have to deal with the problem. That's the second thing. Another thing that I want to talk about is Squelch. So I get this a lot of times. This seems to particularly happen with Sennheiser G3s and G4s. I hear this a lot, but it could happen with anything, right? So what Squelch does is it sets a level that turns off the output of your receiver, right? So if you hooked your system all up, you haven't turned on any of your transmitters, and you're hearing noise, well, that's the Squelch misadjusted, right? Because we just need to adjust the Squelch so that it doesn't allow noise when there's no transmitter turned on. People tell me this all the time. I say, well, what happens when you turn the transmitter on? Well, when I turn the transmitter on, it's all fine. But when we turn the transmitters off, all of a sudden we got all this noise going through our PA system. That's almost certainly a misalignment of the Squelch. So let's kind of look at how this happens. So this isn't electronically what happens, but this is sort of the practical result. When you set the Squelch low, and I'm going to just say that's low, it could be low a lot of other numbers. It doesn't matter what numbers you have. But I'm going to say that Squelch is low, right? So what that means is anytime the signal drops below that red line, the output of the receiver is turned off. In a practical sense, it affects the distance that you can work at, right? So let's just say, so I think every wireless microphone that's manufactured out there, if you look at their spec sheet, it says it has a range of 300 feet. You know, on a good day, it has a range of 1,000 feet. In the middle of Times Square, you may not get that anyway, even with the same piece of gear. Okay, so the question is, do I need to use that microphone at 300 feet? If you're working on a football field, the answer is yes. If you're working on a stage, I've never seen one that big. Stages over 100 feet are rare. And, you know, if you're doing this in a church or a school, your stage might be 40 or 60 feet. So if your receiver can pick up signals from 300 feet away, you don't want that. You don't want the maximum range. The range you want is exactly the longest thing that you need, right? So kind of typically, you know, if you're in a church or an auditorium, you want to take that microphone, the transmitter, and walk to the farthest place anybody's ever going to use it. Might be the back of the hall. And then you can adjust that Squelch down, okay? So now I've set the Squelch line up. I got to tell you that up and down are tricky in this because up to some manufacturers is down to some others, right? But we've raised the Squelch level. So now anything that falls below that line never makes a sound in your system. However, we've cut the range way back, but I'm fine with that. I don't need this mic to go 300 feet, receiver to go 300 feet, an antenna. It's only gonna pick up noise. It's not gonna pick up anything I want. I don't want anything I don't want. If the farthest my microphone's ever gonna be away 63 feet, at 65 feet, I'm great, right? Because it can't go any farther. But these noise levels could happen. So when you turn on your brand new system, you haven't turned on the transmitters, and you're hearing noise, you need to go back and adjust the Squelch. This is not so much a thing on digital wireless mics. Most digital wireless mics don't, they sort of automatically do this, but analog ones don't. So that's why I say G3s, G4s, which are wonderful wireless mics. You just have to understand that when you've plugged it into a new system. So the Squelch is set on those to work at 300 feet out of the box with the whip antennas that came with it, probably, right? All of a sudden, you're going to hook it up with paddles or new antennas. You're going to run it into a distro. You got a little gain from the antennas. So you've got a stronger signal. Again, if I go back to audio, And let's say, you've plugged a dynamic mic, you plug an SM58 into your mixer, you've adjusted the mic trim and everything's cool and groovy with that mic. All of a sudden you unplug that mic and you plug in a hot condenser mic, it just has way more output and it overloads everything. You just have to readjust it. There's nothing wrong with the mic, there's nothing wrong with the board, they're just not adjusted to each other. So understand that you do probably. Now, some people don't do this and they get away with it, right? I never can, it's always difficult when people call me because you can get away with things that are really wrong. If you remember that I preach it in every single one I've done, is that you have to have an adequate dynamic range, usually about 20 dB to lock in your signal. But most of the time you got 30 or maybe even 40. If you've got 30 or 40 dB of dynamic range, you can waste and screw up 20 dB and you're fine. It still works. And as long as it works, right? So I never can promise you that you have to follow the rules. But if you follow all the best practices, again, if you're right down to that 20 dB, your toes are at the edge of the cliff, but you don't fall off. But I want to work 10 feet or 20 feet or 50 feet back from the edge of the cliff, because inevitably somebody's going to walk onto your stage and do something you had no idea was coming and everything's going to blow up. So we want to use all the best practices. That's what this is. We don't want to give away anything, right? We're always dealing with a straw that breaks the camel's back. So if we can inexpensively or free remove straws, that's where we want to go. That's what this is all about. Okay.
Hey, one thing real quick, Don. And don't forget what on your monitors, your receivers that walk out, you should mess with the squelches on those too.
Yeah. So always
same thing.
Yeah, when we talk about, and if ever I talk about a wireless microphone, an in-ear monitor is really the same thing. It's just fed with a line level signal. It's a transmitter and a receiver. So instead of having to say mics and in-ear monitors every time and just make my sentences longer, I just say wireless mics. But they are the same thing, right? So everything that applies to a wireless microphone going from east to west applies to an in-ear monitor going from west to east, right? They're all radios. There's some different levels happening, but they're all radios. So they all follow these same things. So those are the things that I constantly get I get every one of these, every week somebody calls me with this problem. And like I said, the biggest one is frequency coordination. You can't just take these things out of the box. You can't just use the automatic frequency finders, especially if you're mixing brands, right? So the automatic frequency finder things, they have frequencies set for those receivers, assuming that's what you're using. They can't know if you're using something else. And one more mic of one other brand mixed in with what you think is working screws the whole thing up. So you can't do that. If you're using your receiver to scan, scanning's the best way to do this, right? When we scan, provided we've done it correctly, we know what we're dealing with. If we don't have a scan, we're guessing what we're dealing with. Now, we've been doing this for a long time and we're pretty good guessers, but as this band keeps shrinking and shrinking and shrinking, my crystal ball keeps shrinking and shrinking and shrinking, So I can guess, but guesses aren't always right. And if you're calling me and based on a guess, you're going to go out and buy $50,000 worth of gear, somebody's going to get stuck now and then a little bit. Ultimately, we can make it work, but we might have to work a whole lot harder.
Yeah, definitely don't forget to purchase a spectrum analyzer like our two that we have, because you are guessing if you just go by the database. You pull in information, it doesn't know what's going on in your room.
It doesn't know what's going on. Like I said, it doesn't know if you've got an X-ray machine on your station. Yeah. I'm sorry. It doesn't know if you've got video walls. It doesn't know if you've got computers. It doesn't know if you've got people sitting in your congregation with T-Mobile cell phones. It doesn't know if you have LED lighting. It could be anything. Your alarm system, your heating, air conditioning stuff could be working in the frequencies that cause issues. All that stuff. Remember, all radios of all frequencies mix together and create intermod. Obviously, if the frequencies are really, really, really far apart, then what it creates is so tiny as to become invisible and we don't have to worry about it. But things like T-Mobile are really close. Things like video walls are close and may encroach on your low end. Security radios are really close to the low end of where we can tune. So if we have a scanner and we measure with these things, we can scan outside the band. If we're doing it with a receiver that only works in block G50, that's all it can see. So it's looking with blinders. It's better than nothing, but it's not really the right way to do it. So having a real scanner. So I think we got some time here left, Adam. Have we got some questions?
Oh yeah, we got some good ones coming in.
Okay.
So for corporate audio engineer number 2, that would be the assistant, world always seems to be behind massive video walls. Sometimes 60 feet of BNC is needed. What's the maximum length?
I don't know. Depends where you are. Depends what wire you're using. So again, back to a scan. So every time I use coax, I'm going to lose some signal, right? So we're back to that. If I've got 40 dB of dynamic range, I can afford to lose a lot, and it's going to work. If I'm in Times Square and I'm close, it's not. So basically, I'm going to tell you in really big average numbers, you're probably good with RG8X, 50, 75 feet, maybe 100 feet with that. That's the small wire. Don't be using RG58. That's old wire. We don't want to use that anymore. And I get a question every week, oh, we did this with RG6. They look identical. That's video wire. It might work, but all I can say about using video wire is if the manufacturers were okay with you using that, they would say you can use it. They don't say that. They say to use 50 ohm cable. There's some things, basically, you actually end up with a stronger signal, but you end up with a lower quality signal because of some things that happen. So, I'm sorry, was that question in relation to IEMs or with wireless mics?
I believe it was wireless mics. I think in the corporate world, we're typically dealing with Axient systems.
Right. So we have a tool. We have a free tool on our website. If you go to rvenue.com, up at the top level, there's a button that says Performance Tools. That wireless system builder is one. That's all about getting proper frequencies for a location. And the other one is a performance calculator. So you've asked the question, but you've only asked about one thing. You really got to look at 7 or 8 things to understand how long that cable can be. I need to know what wireless mics you're using. I need to know how strong they are. I can tell you handhelds almost always work better than belt packs. So depending on which one you're using, a little more cable length. It depends how close you are to your antenna, right? Because you're going to get a different answer if you're 25 feet from your antenna versus if you're 200 feet from your antenna, because now you're hitting it with a very weak signal. So all of these things interplay with each other, and the program is very simple. It's just drop-down boxes. Tell me which wire, tell me which mics, tell me what distance, and click it. And at the bottom, you're going to get a red light, yellow light, green light. If you get a green light, your distance is fine. In fact, if you get a green light just for kicks, go back and select even a longer distance. You still get a green light, then you're really fine. You don't? Well, then you're kind of close to the edge. But anyway, that's going to give you distances, I think, in 25 feet. And there's some different wire types, so you can try those. So that's a better answer than I can just tell you, because there's not a single number answer to this. It depends on other things.
Got it. Excellent. And by the way, feel free to add your questions into the questions and answers Richard and Bob are answering. There a couple of good ones just came over. So we have another one for you, Jim, here. Dawn, sorry. Do you have a new antenna system that would cover an entire gym without dropouts?
Well, again, if you scan that gym, I can promise you, but I can tell you most times a gym, I assume we're talking about a basketball gym. If that's what you're asking, my first choice would be a diversity fin in any corner of that room. That would cover any basketball gym I've ever been in. They don't have a basketball gym in the middle of Times Square, so I don't have to worry about that. Now, I would also tell you that a diversity architectural antenna is very most likely to work, but it depends if you have any particular, if you have an X-ray machine in the middle of the court, it's not going to work. So in really big average numbers, I would consider a diversity fin is going to do 300 feet with no problem. Now, it may do 1,200 feet with no problem, but beyond 300 feet, I'm going to make a measurement and be sure. I'm going to tell you that a diversity architectural is going to do 200, 250 feet. It's a little less. But that probably is going to work in almost all basketball gyms if they don't have a lot of things creating interference. One of those things that I run into one time was they put it right over the concession. They had a little concession area, and they had a microwave oven. And close enough to a microwave oven, they were getting some noise. So, like I said, if you got an X-ray machine in that room, we really want to measure. Guys, this is just, what we could do today when we hang up and go make this stuff work, we're going to get an answer. But is it still going to work in 6 weeks or 6 months or 2 years? If we measure, I'm a whole lot better about understanding that number.
Great. For what it's worth, we do have a lot of customers adding the D-Arc to gyms because it's a pain point if it gets hit with a basketball, just for what it's worth.
Yeah, if you use a D-fin, if you look on our page, there's a link to a company that sells a plexiglass dome. Because if we're talking about a gym like at high school, a 16-year-old with a basketball goes, I can hit that. And, I don't know how many times you can hit a D-fin with a basketball, but I'm going to guess I don't want to go there too much. So they put the plexi. Honestly, mounting this stuff in schools, and high schools in particular, vandalism is probably as big an issue as making the wireless work. It just happens. Sooner or later, you got kids. What are you going to do? So you need to kind of plan for that. Okay, next question.
Cool. This is a fun one. UHF versus Wi-Fi, which is better?
So wireless, we're talking about wireless mics again, or ears. The frequency that they transmit at, high or low, doesn't really directly relate to quality. Okay? Quality transmitters and receivers relate to quality. So you could have VHF down at 175 megahertz. You could have UHF wireless mics from 470 to 608. You could have 900 ISM band, 9 to 928. There's some stuff that works there. You could have Wi-Fi in the 2.4. You could now have Wi-Fi in the 5 gig range. Any of those things could work perfectly. The question is, what do they have to compete with? So in the 2.4 band, I don't think there's a place left on the planet except, down in Carlsbad Caverns, underground 2 miles. I mean, there's Wi-Fi at every McDonald's now, so there's Wi-Fi every place. I worked with a wireless mic back in the day, 15 years ago, that was a 2.4, and it was great because there wasn't much there weren't many Wi-Fi, access points inside your house. So that worked great. I mean, we did 72 channels for an opera one time, And that worked fine in the 2.4 band because there was no Wi-Fi. But unless you can control the Wi-Fi, you're really probably going to do a lot of interference. And I can tell you, of the 2.4 systems, and there may be something new that I don't know about, but the only ones I've ever got to work are the Line 6 and the Audio-Technica AT10s. The other ones that I've played with are all so touchy that I would just stay away from them. Again, you could be in a spot they work, right? Up on top of that mountain in Idaho, you probably got no problem with anything. But yeah, I would generally advise, if it was me, I'm not buying any 2.4 mics. Then again, you know, if you've got to run 150 microphones, you probably need all the bandwidth you can get. So I've I've worked with the guys at the Super Bowl, right? And they need everything on every channel that there is because, you know, I asked them, you know, he said, well, on game day, we've got 3,000 holes we got to fill. You think your coordination problems are tough. That's not all wireless microphones, but it's radios, right? They're all competing at the same time. Somebody's got to coordinate that. I don't want to do it. But they needed, you know, at the time I could give them 14 more channels on 2.4. They were very happy to pick up 14 more channels. So it's everything, it's always, it depends. That's what I
Gotcha.
can tell you.
Cool.
Okay.
All right, this is a great one. Beyond typical interference in line of sight, what are some of the more subtle environmental factors, an example, specific types of building materials or audience density that can significantly impact a new wireless audio system's performance, and how do you diagnose those less obvious culprits?
Okay. So
That's what people are wearing.
people themselves, yeah, people themselves don't cause a problem unless they block line of sight. You know, if you're wearing a belt pack, right? Radios don't like to be near big salty bags of water, but so that's not really a problem. What's likely a problem is cell phones in their pockets or video that they're transmitting wirelessly someplace. That could sneak up on you. I'll tell you another one that isn't real obvious, but back in the day when I used to test wireless microphones outdoors for range, I would run down, we had this big parking lot. I could go 600 feet, and actually 597 feet. And so, you know, you'd turn it on and you'd start walking this distance, and it was real interesting. It was behind some industrial buildings. If you got near big roll-up doors, big metal roll-up doors, didn't work right there. And then just get past them, it would start working again because you get all kinds of funny reflections and garbage and who knows what, especially off metal. So if you're in there was a famous ballroom that we used to have in the Los Angeles area, and they thought it was going to be real cool, and they hung sheet metal all around they did the walls with sheet metal. It may have looked cool, but it was the stupidest thing for sound, and it was terrible for radios. And so large metal things, you may, even if you're not blocking line of sight, if you have a really big metal set piece, that could be, obviously, video monitors is the one, you know, usually, but they're usually fixed. You don't see people walking around with them much, at least where I go. Maybe they do someplace. So, yeah, again, there's things that could turn on that you may not ever be aware of, like, you know, there may be some wireless control in your HVAC, so your heating and ventilation system, that could kick on. Burglar alarms could transmit a frequency that screws up the key frequency in some of the wireless mics. It's really close. That could happen. You know, one I've had that I don't know the answer to, but I'll tell you because I can make it happen. Transmitters getting really close to cymbals on drum sets when the drummer crashes them. I don't know why I can't explain why that happens, but I've had that happen a bunch of times. So if you're a guitar player is wearing a wireless pack and he's standing right next to the drummer and the drummer can crash a cymbal, that may screw him up. You really just move away or take the sticks out of the drummer's hand. I don't know. That's a weird one, but unusual ones. Richard, can you think of any more
Well,
unusual ones? You just don't
I was
ever
just gonna,
think of.
yeah, I was just gonna say, when you're in a control room and you're around video equipment, some video equipment gives off distinct energy. When you're backstage near, of course, amp racks and other comms, like wired on the wired side of comms, those units will give off noise too. So I've had several situations where the the A2 sets up antennas by that stuff, and you walk up with your spectrum analyzer and you see all the noise, and you just tell them to move your antennas away.
Yeah, I mean,
So
any more. So computer chips
yeah,
transmit RF. And I don't know what there is. I think Cheerios have a computer chip anymore. I mean, every piece of electronics, unless you've got vintage gear, if you've got tube gear or, I mean, older gear, everything, no matter what it is, it could be your amplifiers, it could be your equalizers, it could be your mixers, it could be anything, any video equipment, any other kind of stuff that's electronic probably has a chip in it, and that's probably transmitting something somewhere, and that stuff can divide in frequency too. So you want to stay away from any other electronics as best you can. They could surprise you, but I think that's all the things I can think of that I've ever experienced that I went, oh, I didn't think that was going to happen.
Well, that's fascinating about the cymbal. You've perked my ears up because I've had my ears next to cymbals quite often. Are you saying that the pressure wave of the cymbal moving is
Well,
what's
it
disrupting the
can't
pack?
it can't be the pressure wave because the radio doesn't care about that. I don't know what it does.
Maybe
Maybe
just the
it's
metal
maybe
interaction?
it's maybe it's reflecting something, and because I don't know the answer, but I do know it's an issue, and it's like
Wow.
I don't really need to know the answer. I just move it away. But
Wow,
yeah, I've had
interesting.
that. You know what? Actually, now that I say that, the wireless we probably were using at the time was VHF. So again, it's going to depend what frequency. Everything always depends on everything else.
Well, it's certainly not nice to have your open ear next to a cymbal, so I get it. All right, so next one. What's the best way to be prepared for frequency reallocation in the near future?
Well, you know what? That's an interesting question this week because Trump has called for reassigning the 500s. There's nothing in the FCC had a plan to, we've sold off we sold off the 800s and the 700s and the 600s. You used to be able to use wireless mics all the way up to 900. So that's all clamped down, and it's they give you a runway of 4 or 5 years to get this stuff all in line. There was a plan to sell some additional stuff. It never got said what it was, but it was always expected to be the T band, up to whatever that's channel 17 up to 20, the lower frequencies, 470 to 520, I think. That was going to go away. And that was on the books, right? So the plan for that was clear back under the Obama administration. Obama signed the thing to say, yes, go ahead with this. I mean, you can see it didn't, from Obama, what's that, 10 years ago? It never took place. And in fact, it actually got removed from the FCC timeline in one of those first COVID send you the $4,000 check bills. They passed these bills that are thousands of pages long. Why sending COVID relief money to people includes things about your radio? I don't know, but it did. So they took that off the books, right? But we got to say, as fast as Trump is turning things on and off, I suppose tomorrow he could write an executive order and change that in a day. So I don't know what to tell you. Keep watching the news. I don't really think that's going to happen. But you know what? There's a whole lot of things that have happened in the last 4 months that I didn't think were going to happen. So without getting political, there you go. I don't know. I don't know what to tell you. You could buy radios that can tune very broadly, right? So Axients can tune all the way across the whole spectrum that you can use. The Audio-Technica, no, that's only their in-ears. Their in-ear can tune across the whole spectrum. So that one I particularly like for people that are touring, because no matter where you get off the bus, you can tune, right? So you don't have to worry if there's TV stations there, you've got a place to move. If you're using stuff that's in a fixed band and that band is full of TV stations when you get off the bus, good luck. You're going to have to deal with that, and you may or may not be able to. So there's not I can't really advise you. I don't know. Like I said, there's nothing on the books, but I think 2 weeks ago, Trump told the Congress, let's reassign the 500s. I don't know what he was thinking about putting there, but they left us the 500s, and oh yeah, they stuck 1,000 television stations that used to be in the 600s down in the 500s. So they left us the 500s, but then they went and filled that in with 1,000 stations. So I don't know. There's your tax dollars at work. What can I tell you?
More example of the FCC treating the airwaves like a bank, as I like to say.
Well, so, there's a thing that most people don't know. When they did that, when they sold off the 600s, that actually put money in almost everybody's. If you get a regular paycheck that has taxes taken out of it, you got money in your pocket from that. We don't need to go into it, but so it's not all bad. So I don't know. Anyway, all right, what else we got?
Well, we got one more statement that is perfect leading after that conversation. Basically, I just bought a new RF Explorer Pro and we need to troubleshoot a system. Do you guys have any words of advice for this user?
Yeah, first of all, congratulations. You bought a tool that will allow you to do that. The easy answer is, do measurements for frequency coordination. Now, an RF Explorer Pro will do all kinds of things. You can actually test your coax cables. You can use them to hunt down interferers, which you may or may not be able to deal with, but you actually can trace stuff, right? You can put an antenna and you can actually figure out what corner of the room it's coming from and that kind of thing. You can actually tie it down. There's a lot of things you can do to actually test the quality, what's going on in your transmitter, what's going on in your receiver. But most of those things you don't have to do. The one that you really need to do is run the frequency coordination. Because once you run the frequency coordination, once you run the scan, excuse me, I said wrong words. You run the scan. You can scan the area. Now, scanning, so you can use the little whip antenna that comes with that, and that's an Omni. That's going to scan the room for everything that's there. So if it's a new installation, they've never put, you're not even going to install this stuff for 3 weeks. You can go measure the building and see what's there, what residual stuff is there, right? In that case, using an Omni antenna is fine. If your system is all built, everything's wired up, this is all working like we were talking about earlier on, you would be better off to connect to the antenna that's feeding your receivers. Because if the antenna can't pick up stuff, then I don't care about it, right? So in other words, the easy example is RF noise coming from behind you is essentially not going to make it into that antenna. That antenna won't pick it up very well. So we don't have to count that noise when we're doing a coordination. And so again, this is giving your program better data. So we really only care what the antenna feeding your receivers can do. So in that case, if you have a spare output on your distro, you can use that. Or if not, you can use a 2x1 splitter and tap off it, or you can simply disconnect one side of one receiver, while you're measuring, and that's the better thing to do. So you definitely got a full-on pro piece that you can do all kinds of cool stuff with. And because it'll do so many things, there's a learning curve to that. You're going to have to, play with that a little bit and go through it. The easy way is if you get our Spectrum recorder, which is a tool that basically is set up just to do frequency coordination. That's what 98% of our users, I'm making up numbers, but a really huge number of people really only need to measure their room and get a scan for frequency coordination. But RF Explorer Pro, great piece of gear. Love mine.
Awesome, Don. Great answer. And certainly, we're experts on this tool here. So feel free to reach out to us. info@rfvenue.com. Richard, Bob, myself, and Don, we're always happy to do any training on the RF Explorer Pro. We know it's kind of daunting and there's a lot to it, as Don said. So we're happy to work with you directly anytime you need assistance or just have a question about buying one. So definitely let us know. Really thank you guys for all your time. That brings us to the end of this session. I'm going to send you a feedback survey. Definitely let us know how we did, and if there's any topics you'd like us to cover in the future. We're always happy to explore different topics because we're all covering the same thing all the time pretty much, and we like to get fresh ideas and fresh concepts out to you guys. So thanks so much, everyone. Thanks, Dawn. Thanks, Richard. Thanks, Bob. And look out for the next webinar next month. Thanks, guys.
Thanks, guys. See you later.
Take care.